User onboarding and user experience continues to be a challenge for developers of Web3 applications today. To onboard the next billion users onto Web3, we need to be able to mimic the experiences that users are used to coming from Web2 as they begin to use Web3 applications. Non-native Web3 users may struggle to open a wallet to store tokens and may also struggle to find ways to get tokens into that wallet. And as such, they will struggle to complete onboarding for Web3 applications. In this tutorial, we will go through how to remove the need for users to have to acquire Tez or to get Tez tokens in order to interact with your decentralized application. You can follow along and read an expanded version of this tutorial by going to the blog in the link in the description below. Now, picture Instagram being a Web3 application. For every time users have to send a DM, leave a comment, like a picture, or make a post, they would need to pay gas fees for each of those transactions. What if there was a way for developers of decentralized application to cover gas costs or gas fees for users of their application? And this leads us to the idea of meta transactions. Now, let's talk a little bit about meta transactions. Meta transactions allow developers to improve the user experiences within their application by removing the need for users to hold tokens in order to interact with a dApp. This is achieved by separating the transaction sender from the gas payer. The gas payer could also be called the relayer. And there are two types of meta transactions. We have the gasless transactions, and then we have gas abstraction. Now, gasless transactions are transactions that require the users to pay zero gas, so users do not need to pay any fees in order to interact with your dApp. And then gas abstraction. With gas abstraction, users can use any token of their choice to interact with your dApp. Now, both gasless transactions and gas abstraction work because of the relayer. You can think of the relayer as a wrapper around the transaction or an API that forwards transactions to the blockchain and pays gas fees on behalf of the user. The TZIP17 proposal, also called the permit proposal, is a standard on the Tezos blockchain that allows us to send pre-signed transactions on behalf of a user and also to pay gas fees for them. To perform gasless transactions, we can use the gas station as a relayer. A gas station is simply a smart contract wallet that forwards transactions to the blockchain and also covers gas fees on behalf of a user. In the rest of this tutorial, we'll use a voting dApp to demonstrate how you can use a gas station API to send transactions on behalf of a user. We'll be making some changes to an already existing smart contract code for a voting application. Now, let's take a look at the smart contract code. All right, so we're going to navigate to the SmartPy IDE, which is located at smartpy.io/IDE. We're going to start with a boilerplate smart contract for a voting dApp, which we wrote in a previous episode. And you can see the link in the description below. In our previous voting smart contract, we had the sp.sender, which is basically the sender of the transaction. So the person that is signing the transaction, we can get their wallet address or their sender address by tapping into sp.sender within SmartPy. But for the purposes of this tutorial, we're actually going to change this up. So we're actually going to use params.useraddress rather than sp.sender. We're also going to change this to params.useraddress as well. And we're going to update our test as well to reflect these changes too. So instead of signing the transaction as Bob, we're going to take this out and we're going to say user address here as another parameter, and we're going to say bob.address. And we're going to repeat the same thing for the rest of our test. Now, once we're done making our changes, let's run the code to make sure that everything works correctly. And as we can see, everything works fine. Our tests still run as normal. So next step is for us to deploy the contract. Click on deploy Mikkelsen contract. So click deploy Mikkelsen contract again, switch this to the ghostnet, select account. Don't forget the account that you're deploying this contract from. We're going to deploy this from account 3. Click on validate. Click on estimate cost from RPC. Click on deploy contract and then accept. Sign the transaction. Now, once the transaction is signed, let's head over to our gas station UI. Now, click connect wallet. We're going to connect our account to the gas station API. Select account 3, click connect. Now, once we click connect, we'll be able to add a contract to our gas station UI. But before that, we need to go back to our smart contract IDE or to the SmartPy IDE copy your contract address, come back to the gas station API, click add contract, paste your contract address in here, click fetch entry point, and you get to give your contract a name. So we can call this voting dApp. Now we need to toggle on which entry points we would like our gas station to have access to. If you have multiple entry points within your contract, you probably only want your gas station to have access to one or two of those entry points. And so for this purpose, we're going to turn on the increase vote entry point, and we're going to click add. Now, once we do that, we can see that our smart contract is already added to our gas station. The final step is to add Tez to our gas station API. This is the Tez that is going to be used to fund our gas station transaction. And so once you're here in the gas station UI, right now it shows the balance in the wallet that we have connected. And so we can add one Tez to this. We can click on one, we can say one, and then we can click add Tez. That will load up our wallet for confirmation. And now when we refresh this page, we should see that our balance has reduced. So some of this money has gone into our gas station API. Now, the next part of this is making some changes to the front end of our application. We'll need to first update the contract address to reflect the new contract that we've got. And so we're simply just going to copy our contract address and paste it in here. And once we have that done, we can head off to our index.js file and continue to make changes to our application. Now, before we add any changes to our index.js, the first thing that we need to do is we need to install Axios. Axios allows us to call third-party APIs. And to do that, simply type npm install Axios in your command line on your terminal. That's going to install Axios within your project. And once that is done, you can X out of here. Once that is done, simply paste import Axios from Axios in here. And finally, we're also going to import our gas station API URL as well. To start off, we need a button that users can click to connect their wallets first so that they can pre-sign these transactions. And I'm just going to create the button here. Now that we have the button created, the next step is for us to make sure that we can get the user's wallet address once they connect their wallet to our application. To do that, we're going to use useState again, the useState hook in React. And I'm just going to say user address, set user address equals useState null. And so that we can set the states later on. Now, if we scroll down to our connect wallet function, as you can see from our connect wallet function, not a lot has changed. The only thing that we're going to change is this line where we assign the public key hash to the user wallet address variable, and then we set the user address to user wallet address. Now, once that is done, the final step is to connect to our gas station API. And in our call gas station function, once we get into the function, we want to show the user a message that we're awaiting confirmation. And then we're going to use the Tezos instance and the wallet APIs of Taquito. We're going to get the increase votes entry point, which is a method in our smart contract or an entry point in our smart contract. It accepts two parameters. It accepts the player ID and it also accepts the user address. And so we can pass these two parameters into our increase votes entry point and call to transfer params method on it, which is going to give us some operation parameters to use. We're going to feed some of the data that we're getting as a response from the to transfer params method into our API. So we're going to make an API call to the gas station API URL, and we're going to add the operation endpoint. And we're going to pass operation.to, which is coming from what we receive here from calling the to transfer params method. And we're also going to pass the parameter as well. And then we're going to get the result object out of response.data. And if it's true, we're going to display a message of vote confirmed, and we're also going to reload the application. And let's go to the front end of our application to make sure that everything works correctly. The first step is to connect a wallet. So click on connect wallet. And let's connect a different wallet from what we use to deploy the contract and to connect to the gas station API. So I'm going to select account 2 here, and I'm going to click connect. So let's vote for Cristiano Ronaldo here. And you can see the vote has been confirmed. And if we refresh our screen here, we should see one vote for Cristiano Ronaldo. In this tutorial, we've learned how to improve the user experience for our users by ensuring that users can simply use our application without the need to pay gas fees. We send these transactions to a relayer called the Gas Station API that routes those transactions to the blockchain. And by using the Gas Station API, we hope that users are able to have a better onboarding experience and better user experience using Web3 applications.